Morning, geometry students. Mrs. Suya here. Today's video is going to continue our review of solving quadratic equations. These ones are level 2, so they're going to be a little bit harder than the first video, but we are still only in the realm of the square root method and then the factor and zero product property method. There's actually quite a few, there's 3 other classic ways to solve quadratic equations, but we're only exploring these 2 ways. Okay, so first of all, just a reminder, quadratic equations are equations with an exponent of 2. Highest exponent is 2. So all of these are quadratics. And this one kind of tells us to use the square root method, but just if it hadn't, we would look at our equation and the only x term that I see in here is just the one that's being squared. And so that's a big hint that we will be able to use the square root method. All right, so to use the square root method, we have to isolate, that means get all by itself, the squared part, the part that the x is, where the x is. So before I do any square roots, I'm going to subtract 12 over to the other side. All right, then I'm going to take the square root of both sides, hence the square root method. Okay, and remember that when you do the square root of both sides, we explored that in our other video, that there's always the positive and negative of that answer. This happens when you're solving equations. You get the plus and minus at the step where you're doing the square root. Okay. Number 2, same setup, right? There's only an x squared part. There's no other random x that's in there. So we're able to isolate the x squared part all by itself. Okay, so in this case, when we do the square root of both sides, that's not a perfect square. So we have to do the breakdown. Don't forget, we still have the plus and minus option at this step right here. So plus and minus. And 24, the best breakdown for 24 is 4 times 6. Okay, and number 3 looks more complicated, but notice the part where the x is, the whole thing is squared. That's a perfect square, and there's no other x's in here anywhere. So we're going to go ahead and minus the 3 over to the other side. Take the square root of both sides. At this point, don't try to do anything with that exponent of 2, right? This entire side is a perfect square, so we're just going to undo that by taking the square root. Okay, so it's at this step where we do the plus or minus, right after you do the square root. So that side just becomes x minus 5. 9 times 2 is the best breakdown for this. 9 times 2, because then we can get a perfect square of 3 out of there. 3 root 2. Okay, and then we're just going to add 5 over to the other side. And remember, we can't combine anything here because this is just a 5, and this is a plus and minus 3 with a root 2 on it. So even though these answers look kind of funny, this is still standard radical form, or that simplest radical form. 5 plus or minus 3 root 2. The 5 just has to stay separate. It doesn't join in with that 3 in any way. Okay, so for 4, 5, and 6, I mean, it does tell us that we're going to use the factoring and zero product property method for this. So what forces us to do that is notice that there's an extra term in here. There's an extra n in here, I should say, unlike up here where there wasn't. So if there's an extra n in there, we can't really ever get to this step right here. So we can't do the square root method. All right, so for this method, the zero product property means that we have to have it set equal to 0. So I'm just going to minus the 21 off of the right-hand side and minus it off the left-hand side. I didn't show a work step, but it would look like that, right? Subtract the 21 from the right-hand side, so that side is 0. I mean, when you subtract it over here, there's really no place to put it. So we're just going to keep it, we just write it off to the end like that. Okay, so now it's a trinomial. It goes n squared, then n, then just a constant term, So we are going to factor it into two binomials. Okay, and these ones are the ones where that is the two first terms multiplied, so n and n make n squared, and then the last two numbers, or the last number here, has to come from the second number in each binomial. So we know it's going to be some kind of 3 and 7 combo, because, well, we'll just do it the long way. So -3 times 7, or 3 times a -7, right? We're looking for two numbers that multiply to make this, add to make a +4. Nope, not that one. This one. So we're going to put the minus with the 3 and the plus with the 7. All right, so that's the factoring. And zero product property is where we say, hey, look, this number n minus 3 times that number n plus 7, they're getting multiplied, and their answer is 0. So I know the n minus 3 number has to equal 0, or the n plus 7 number has to equal 0. Okay, and again, I didn't say it, but just quadratics have two answers, right? So those are the two answers for this quadratic. That's two answers because it's both the positive and the negative. Two answers and two answers. Okay, so here, same dilemma. We want it to be set equal to 0, and even though it's a little faster if I did minus x squared over to the right-hand side, I encourage you to always keep your leading term, x squared term, positive. I'm going to erase that. Right, so that means that I'm going to minus the 12, right, off of this side, and I'm going to add the 4x to cancel that, and add 4x on the other side. So even though nothing over here combines, right, it's going to look like this. I'm going to put it in the right order. X squared plus 4x minus 12 equals 0. Okay, oh, I didn't notice I had made it so crooked. Alrighty, so we'll go ahead and factor it. What two numbers multiply to make -12, add to make 4? So, you know, -12. I'm thinking it's some kind of 2-6 combo, right? 2 and 6. Let's see, if I make the 2 negative and the 6 positive, right? When I combine those, they're going to make a positive 4x. X, X. So I'm going to make the 2 negative and the 6 positive. And I always just do a little mental check, right? X squared plus 6x minus 2x. That's a 4x minus 12. All right, and then don't forget to actually solve it. Sometimes people just get it factored and say, oh, the answers are -2 and +6. But really, the answers are +2 and -6 after it goes through the zero product property. Okay, and this is just one of the trickiest ones out there. Everybody, when they see this, they at first want to just divide away an x and call it good. But just keep in mind that dividing away an x is never a solution, a way to solve a quadratic equation. Not in Algebra 1 it wasn't, in geometry it won't be in Algebra 2 or pre-calculus or calculus. You just never solve these equations by dividing away an x. It's quadratic. It's not a zero, or it's not a square root method, which means it's going to be the zero product property method. So we are going to subtract the 5x to the other side and get it equal to 0. And now the factoring is just a little different because it's really not a trinomial. It's only a binomial, in which case all we're going to do is factor out the common factor. We're going to do the greatest common factor factoring. In this case, it's just an x, right? You're going to divide an x out of each one, but the 3 has to stay there. If you remove one x from here, there'll still be one left. Remove an x from here, divide it out, right? That's the factoring process, divide it out, equals 0. Zero product property, x equals 0, whatever. This is the a part, and this is the b part. So you'll get a fraction, and that's okay. So 5/3 and 0. It's kind of low on the screen there. All right. Okay, so the next set of problems, 7, 8, 9, and 10, I would recommend that you pause for a minute and see if you can solve those. So part of the challenge is identifying which method you're going to use and then actually solving it. Okay, so at the risk of this video getting a little long, I'm going to go ahead and go through the solving. So if you don't need to watch me solve it, then you can fast forward through this portion of it. But if you're still stuck, then just kind of watch as I go. So this only has the 1x squared term, which means I'm going to use square root method. It's just like number 1 above, right? X squared equals 9. Take the square root of both sides. X equals positive or negative 3. Okay, number 8, with another x in there, we cannot use the square root method. So this one has to be this method, factor slash ZPP, zero product property. So we're going to factor out an x is all we can do here. Okay, and then zero product property, x equals 0 or x plus 3 equals 0. I know on some of these, especially as you get better at them, people just start doing a lot of stuff in their head. I just encourage you, at this level, you still need to be showing your work steps out and writing out your work. So don't skip steps. I know they're irritating sometimes, but kind of when you get into Algebra 2 is when you can start skipping some of those intermediate steps or beginning steps. Okay, number 9. The entire left-hand side is a perfect square, right? The whole x plus 3 is a perfect square. And there's no random x term, so this is appropriate for square root method. Take the square root of both sides. X plus 3 equals positive or negative 6, right? That's when we do the plus or minus. Now, this one we're going to do, I'm going to break apart into 2 equations because we can actually do the workout on each of these. Unlike number 3 above, we couldn't finish it because the right-hand side was not a perfect square. But in this case, it is. So here's my 2 answers. One of them is going to be 3, and the other one is going to be negative 9. Okay. All right, and last one. It's got an x squared term and an x term, so square root method is off the table. We have to factor and do the zero product property. So I'm going to add 5x over to the other side, add 4 to the other side, so it's set equal to 0. You can't do anything until it's equal to 0. All right, and 2 numbers that multiply to equal 4, add to equal 5 would be a 1 times 4. And then we'll just zero product property. Kind of looks like 11. There we go. Okay, so on the back side of the notes, we have not done this type of factoring yet, this harder type of factoring. So this, we need to review this. You should have done this factoring in third quarter last year, but I know just in general when students come to geometry, they're not very good at it. Nobody likes doing it. It's kind of painful. So we're going to do it. It's called factoring trinomials with a leading coefficient other than 1. All right, so a trinomial as in 1, 2, 3 terms. The leading coefficient is that leading number there where the a is. So all the factoring that we've done into the two binomials like this, they've all been when the leading term is just like x squared, right? A squared, n squared, whatever. Now there's going to be another number in the front, like that 3 right there. Okay, so we're just going to first multiply these two binomials together to inspect what is happening. So if we go through that first, outer, inner, last procedure, we're going to get a 2x squared. That hasn't happened yet for us to have a number in the front there. All right, minus 3x. This is a plus 16x. So notice what that extra number in the 2 did is it multiplied by one of my OI terms, what I call the outer and inner together, the OI term, right? It made that, instead of just being an 8x, it made it a 16x minus 24. So final answer, 2x squared plus 13x minus 24. All right, so just kind of an observation. The first two terms remained kind of easy to tell where they came from, right? If I'm thinking about taking my my answer, my trinomial, and taking it back up to here, my last term, that's kind of easy to see because 8 and negative 3 did make negative 24. But the hard part is this OI term right here, because when there's no number in the front here, then that OI term really is just a combination of two numbers that multiply to make the last and add to make the middle. And that goes away right now, right? Because look at the two numbers that it is 8 and negative 3. 8 and negative 3. Those add to make 5. If I was going to use my old method, right? They don't add to make a 13. So this middle term is really no longer helpful for choosing what my two numbers are going to be here when I'm trying to factor. Okay, so looking at number 12, what we're going to do on this one is factor it. It's a trinomial. There's a number in the front, and that's going to just mess all of our factoring up. Okay, but we're going to keep in mind that the 3k squared comes from the first two terms multiplied out. So one's going to have to be a 3k, and the other one's going to have to be a k. And it wouldn't matter where I put the 3. I just happened to put it in the first one. Okay, let's see. The last terms, the last term has to come from two numbers that multiply to make 40. So we're going to go ahead and just, is it 1 times 40, 2 times 20, 3, not 3, 4 times 10, and 5 times 8. Notice, you guys, none of these are going to combine with addition or subtraction to make negative 29. And that's what happens when you have a number in the front. So you can't use that, that logic of two numbers that multiply to make the last, add to make the middle. You're just going to go with some trial and error. And again, I'm going to kind of write it out, but I'm going to choose, a lot of times I choose the two numbers that are closest together in all my little pairings, all my little options, because that just seems like it does end up working sooner first, but that's not a hard set rule. It's just a good place to start. And I can tell by the signs that both of these have to be negative. If they're both positive, there's no way for me to get a negative middle term. And they can't be opposite signs because that would give me a negative on the last. Okay, and then I'm just going to do a check. And I do this in my head. I'm writing it out here, and then I'm going to erase it. But, you know, if I'm going to check it, I got to go through kind of FOIL in my head, right? 3k times k, that's 3k squared. I'm not even going to write it because that's always going to check. I don't need to check the first term. I need to check the OI. All right, so 3k times 8 is negative 24k, and negative 5k, negative 5 times k is a negative 5k. And look, oh, I didn't necessarily mean for that to happen right away, but there's negative 29k right there. Right, and then the two last terms, they're going to check. That's how I picked my numbers in the first place. So I'm just checking the OI part. Right, so when I do this in my head, I'm just like negative 24 minus 5. Oh, yeah, that's negative 29. Right, I'm just going to multiply, combine with what the signs say, and hope to get the middle term. Okay, we'll have to do more trial and error on the next ones. Now, notice this one is not a solving one, right? 13 and 14 are equations, so you would finish with the zero product property, but this one just said to factor. So we end this problem right here. Don't need to do anything more with it. When we come down to number 13 and 14, it is an equation, and it's quadratic. And so we can't use square root method. We have to do the factor and zero product property. And these are just these ones, I tell you, people skip them all the time because they're just too much work to factor. So don't skip them. You never get better at them if you just always skip these ones. And this is a skill you have to have if you're going to survive in Algebra 2. You can't be in Algebra 2 and just skip stuff that you don't feel like doing because it hurts your brain too much. Okay, so here's what we know. 5p is the first term. This is my OI term, and that's the last term. So 5p and p. Okay, and when I think about all the different combinations to get a negative 12, right, we have negative 1 times 12, 1 times negative 12. The signs have to be opposite, right? Negative 2 times 6, 2 times negative 6, negative 3 times 4, 3 times negative 4. I don't always sit there and write out all the plus and minus combos. None of these are going to add to give that, correct? And that's because there's this other number that's messing with your OI term now. All right, so I'm just going to try, one of these combinations right here, the 3-4 combo. I'll just try the minus 3 plus 4. And again, if you can see, I'm going to do it in my head. I'll write it out, but 20, the OI term, right? That's 20 minus 3 is a 17. That's not negative 28. If you're wondering what I just did, I did the check, right? Don't check the first. We're just going to check the OI part. Don't check the last. We're going to go 20p minus 3p. That has to make the OI term. And if it doesn't, you got the wrong combination. Now, normally we would just go up and be like, well, let's go on to the 2-6 combo. However, because it's different if you switch the 3 and the 4 around, we're going to go ahead and switch the 3 and the 4 around. So I'm going to put the 4 here and the 3. And it's different because in this combination now, look, the 5 is getting times by the 3 instead of the 4. All right, so that's going to change my OI. But again, I kind of do this either on scratch paper or I do it in my head. So that's what? 15p minus 4p? 11p? Nope. Still not right. Okay, so we've tried the 3-4 combination, and I'll tell you how to handle the signs, but we haven't come to the right answer yet. If you don't get the right number there, positive or negative, then these are not your solutions. Okay, so we're going to go up and erase, right, and go on to the 2-6 combo. Okay, so let's try the minus 2 and a positive 6. So the OI term is 30p minus 2p. Oh, this is good news. Look, we got a 28. Now, we got a positive 28, and we need a minus 28. So it's a really easy fix, right? So let's just kind of work our way backwards through it. To get a minus here, I would need a minus here and a positive here, right? To get a minus 30p, I would need this to be a minus 6. And to get a plus 2p, I would need this to be a positive 2. Okay, now it's factored. Now again, this I do on scratch paper, or I just do it in my head, kind of trial and error procedure. And now we just ZPP, zero product property. 5p plus 2 equals 0, p minus 6 equals 0. So negative 2/5 or 6. All right, one more. So observation, right? It's quadratic. There's an extra variable in there, so you can't use the square root method, right? So we're going to go ahead and subtract the 56 over to the right-hand side, left-hand side, so that it's equal to 0. Alrighty. Let's see, 3, and so we need a 3b and a b. Okay, and 56. Now it's a negative 56, but I'm not going to do the whole plus minus because that's just kind of tedious. But I always usually do like to write my combos, right? 1 times 56, 2 times 28. Is it 4 times 14 and 7 times 8? Okay, so of all the combos, right, I would try for this one first and then work my way up the chain. Okay, so again, because this is negative, I'm going to have one of these be negative. So I'm just going to be like, hey, minus 7 plus 8. Now, can we do this in our head, right? This is going to be a 24 minus 7, right? When I do my OI term, so I'm just going to do the OI, right? 24 minus 7b. That's not it. That's 14b, and I need a negative 13b. All right, so let's go up and swap the 7 and 8. And I'm going to get a 21b minus 8b. That's looking a lot better, right? 21b minus 8b. So that actually is 13. 21 minus 8 is 13b. That's perfect. It's not perfect, but it's really close. So remember our trick. We got the right number with the wrong sign. So all we have to do is jump up here and swap the signs, just like we did it slower on number 13. Swapping the signs gives me a negative 21 plus 8. That gives me a negative 13. Okay, so then I'm going to just go ahead and I'm going to erase this. Again, I usually just do that in my head so I don't have writing there. So I can finish the problem with ZPP. 3b plus 8 equals 0. b minus 7 equals 0. So negative 8/3 or 7. All right.